Hi everyone and welcome. In this tutorial, I will show you how to add FFmpeg to an N8N Docker container. FFmpeg is one of the most powerful tools available for processing audio and video. It can convert files, compress videos, extract audio, create thumbnails, change formats, and handle many other media tasks. When we combine FFmpeg with N8N, these tasks can become fully automated. For example, N8N can download a video, send it to FFmpeg, compress it, extract the audio, and upload the final files automatically. And instead of paying for an additional media processing service every month, you can perform many of these tasks on your own server. There is one important challenge. However, the current hardened N8N Docker image does not let us install FFmpeg using the usual community commands, but there is a clean solution, and I will walk you through it step by step. First, we need to identify the N8N container that is already running. The Docker ps command displays all active Docker containers. The grep N8N part filters the result, so we only see containers related to N8N. In my output, the container is named N8N. We will use this container name in the next commands. Your container may have a different name, so check your own output carefully. Next, I am checking the operating system inside the N8N container. The docker exec command allows us to run a command inside an active container. The output shows that this container is using Docker hardened images based on Alpine Linux. A hardened image is designed to reduce unnecessary software and limit the number of components that could create security risks. Think of it as a minimal and locked-down operating system. It contains what the application needs, but it removes many tools that are normally available in a complete Linux installation. Now, let us check whether FFmpeg is already installed. The error says that the FFmpeg executable cannot be found. This confirms that FFmpeg is not available inside the original N8N container. You may find tutorials that recommend using pk add ffmpeg or apt install ffmpeg. Those methods work in many standard Linux containers. However, this hardened N8 runtime image does not include a normal package manager such as apk or apt. That is why those community installation methods may fail on this version. Instead of modifying the running container, we will create our own N8 image that already contains FFmpeg. This is also more reliable because the installation becomes part of the image itself. Now, run this command in the terminal. This command displays all N8 and Docker images available on the system. From the output, we can check which N8N image versions or tags are currently installed. Before continuing, let us quickly understand the difference between a Docker image and a Docker container. A Docker image is like a reusable template. A container is a running copy created from that template. The official N8N image does not contain FFmpeg. We are going to build a new template that contains both N8N and FFmpeg. We can then use that image to create one or more containers whenever we need them. Now, I am creating a file named Dockerfile. A Dockerfile contains the instructions Docker will follow when creating our custom image. Enter the following lines. This Dockerfile uses a method called a multi-stage build. Do not worry about the technical name. The idea is simple. The first line opens an image that already contains static-ffmpeg version 7.1. We name this temporary stage FFmpeg. The second from line opens the official N8 image. This will become our final image. The two copy instructions take only the FFmpeg and ffprobe programs from the first image and place them inside the N8 image. The value 755 gives the programs permission to run. ffmpeg performs the actual audio and video processing. ffprobe inspects media files and provides information such as duration, resolution, codecs, audio tracks, and file format. The final image contains N8N. ffmpeg, and ffprobe without requiring APK or apt. Save the Docker file and exit the editor. Now we will build the custom Docker image. The Docker build command starts the build process. The T option assigns a name or tag to the new image. I am naming it N8N with FFmpeg. The F Dockerfile option tells Docker which file contains the build instructions. The dot at the end means that Docker should use the current directory as the build context. During the build, Docker downloads the required images, copies ffmpeg and ffprobe, and creates the final N8N image. The first build may take some time because Docker needs to download the required layers. Once the build is complete, we can list the available N8N images. The output now shows two images. The first is the original official N8N image. The second is our custom image named N8N with FFmpeg. Notice that the original image has not been deleted or modified. We have created a separate image, which makes testing much safer. This custom image can be used with the normal Docker run command. It can also be used inside a Docker Compose file or a Portainer stack. For example, instead of using the official N8N image in Docker Compose, you can use N8N with FFmpeg latest image. For production use, it is better to replace latest with versions that you have already tested. This prevents an unexpected update from changing your working setup. Now I will launch a test container from the custom image. The D option runs the container in the background. The container is named N8N FFmpeg. I am mapping port 5679 on the server to port 5678 inside the container. This allows the test container to run beside the existing N8N container without creating a port conflict. I am also using a separate Docker volume named N8N_data2. This keeps the test container's data separate from the original N8 installation. Finally, N8N with FFmpeg latest is the custom image we just created. This is a safe way to test the new image without immediately replacing the current N8 container. Running Docker PS again shows both containers. The original N8 uncontainer is still using port 5678. The new N8 uncontainer with FFmpeg is using port 5679. This confirms that both containers are running independently. Now we will perform the most important test. This command runs FFmpeg inside the new container and displays its version. The output shows FFmpeg version 7.1. It also displays the available libraries and codecs. This confirms that FFmpeg was successfully copied into the custom N8N image and can run inside the container. In the original recording, you may notice a warning after the version information. FFmpeg officially uses a single dash for this command. Use one dash before the word version. Even when the version information appears, using the correct command prevents the extra option error. For comparison, I am running the same command inside the original N8N container. The original container still reports that FFmpeg cannot be found. This is expected. We did not modify the original image or container. FFmpeg is only available inside the new container created from N8N with FFmpeg. This comparison proves that our custom image is working exactly as intended. Before replacing your production N8N container, create a backup. Make sure you preserve your existing data volume, environment variables, database settings, encryption key, domain configuration, and reverse proxy settings. The test container in this tutorial uses a separate volume. When moving to production, use the volume and configuration that belong to your real N8N installation. Do not delete the original container until the custom image has been fully tested. And that is how you add FFmpeg to a hardened N8N Docker container without using APK or apt. You now have a reusable N8N image that includes both FFmpeg and ffprobe. I hope this tutorial made the complete process easy to understand. To see a practical workflow showing what N8N and FFmpeg can automate together, write the word "more" in the comments. And subscribe to the channel for more practical tutorials about N8N, Docker, Linux, automation, and self-hosted tools. Thanks for watching, and I will see you in the next video.